Hello everyone. So today we would be discussing about multimodal embeddings. So I just wanted to ask one question, like have you ever seen like converting video into embeddings, or maybe have you ever worked on converting the video into embeddings? Like can you raise the hand? Okay, I can see only one or two hands. Uh, so there are like lot many problems when we talk about video embeddings, and that's what we will gonna discuss about how to efficiently build an embedding around videos, and also how you can do cross-modal retrieval. And about myself, myself Rishikesh Yadav, I am a developer advocate at TwelveLabs. I am also an applied generative AI researcher, and you can find me building something new every day. So we'll just understand about video understanding, and video understanding is a new domain, I can say, in an applied generative AI, which solves a lot of problems. The first problem is tagging. Whenever we talk about videos as a collection of videos, maybe video stock footages, or maybe an event videos, we need to actually write the title or the description, or at least have a keyword, so that whenever we need to find that video again, we need to, we'll just get that. We doesn't actually look on to what's inside during the search, right? Like if you have used like Google Photos or Apple Photos, you might have realized that whenever you search that, the relevant images you get, but for videos there are nothing, because it solely based on tags, and tags are time consuming and inconsistent. The next thing is the search. So as I told, like searching a relevant video for any use cases, maybe if you need it for video editing or you need it for any other purpose, it's very difficult to get a most relevant videos, because you need to watch it to get the exact moment. The third problem, the LLM doesn't understand actually the videos. So we still process the videos as a very traditional way. We convert the videos into a collection of frames of images, and then we make an image to embeddings, which is very inefficient, because there are three losses. First, the video associated and the associated corresponding timestamp get lost. The second thing is the audio is not synced with the set of that or the clip of that video. And the third is the most relevant, which is the temporal dependence, the flow. Because if we talk about the various LLMs which has been taken into consideration for the video understanding, it takes only one frame, or maybe one frame in a 2 seconds. So there are like loss of information a lot. So these are like the major problems in the video understanding. And we would be discussing about how you can leverage the embedding model to get it like in a better way. So here I am presenting to you Merengo 2.7. So the architecture of Merengo 2.7 is very different, because it has an encoder which actually preserves the temporal dependency. We'll see the high-level architecture of that, but we'll understand like with the model, you can embed video, image, audio, text, like any modality, which is the best, because in one collection, you have all the modalities. So here you can see there is an image, video, audio, and text, and everything has been embedded and stored, like you can store it into vector database. So if we see as the architecture-wise, when the video has been provided, the video gets converted into two segments first. First is the visuals, and second is the audio. Then there is a dedicated encoder architecture, which converts the visual into a vector representation and audio into a vector representation. And at the last, there is a gated fusion module, which clubs the both, and we get the multi-vector representation. If we just see the use cases around it, it's like, let's say, if you want to find a logo from a video and find a particular moment where actually the logo has been found. So here you can see, identify the Chase Bank logo, and I have also provided the image. And next, you can see here, like it's very complicated to find out like where this is, but it find out and the exact time duration also. Second is like text to video. So it's like if I just search around, okay, multiple New England Patriots pressure and specific moment in the sports, so that can be found. Or audio to video, which is like if you wanted to find a violin sound and you have a whole database where you have stored all the videos and you want that exact moment which you can found. Here you can only see the video, but if we just see the whole response, how it looks like, it have a start time, end time, the clip, in clip how many times that it appeared and specific to that object to object, what's the start and the end time. And if I talk about the evaluation or the performance, so you can also check it in the technical paper of Marengo 2.7, but it works very well if I talk about image search in the videos or the motion search specifically. Now we will be looking towards video to video recommendation. This is one of the, I can say, an integration or a product which I collaborated with Qdrant way long before. And here is the demo. Here you can see like, I just came here and wrote a sci-fi and I want like a dark theme, reels, animated reels kind of. And from the Qdrant, it fetches the videos. Here you can see Wally in a dark mode and the whole dark scenario. If I just change my mood to action base, so I get reels around action. And the thing here is, none of the video is being tagged or keyword has been provided, and there is no description of that. But still, it was able to understand what's going on in the video and get me the relevant video out of it. So this is the way how these, when you need a very specific thing, it changes the way you interact to find or retrieve the video specifically. So if let's say you have a video stockage, like lakhs of videos, and you want to find a very specific thing, or maybe if you have like a galleries of videos, like having a collection of videos, and you want to find where you have recorded your ID card and you want that detail, so you can just search around it and you will get that exact moment with the details of that ID card. So this is the way like many things can be searched, which is like critical. Here is the link of the repository if you want to look at the code. Everything is open source, and also we'll be also discussing about how you can build this type of an application with just a 4 snippet. So we'll move to that. Yeah, so first task here comes is the embedding generation. So here you can see the list of video contents. And now I'm just providing like hundreds of 1,000s of videos to Marengo Retrieval 2.7. And I can do an embedding as in like a whole one video, like a 1 minute into a one embedding, or I can convert 1 minute of a video as 10 seconds clip as far as like as I configure as a parameter. And as per that, I do, oops. As per that, I do the embedding. And then I have the embedding, and also the metadata is necessary because we need a URL, right, if we have it on a local. So via S3 bucket, and now we have the embedding being generated. So here you can see it's so easy that you just need to configure TwelveLabs client.embed.task and the model name, and here is the video path, and here is the whole video. Next step is the Qdrant insertion. As soon as your embedding is created, the whole thousands of videos need to be stored into a vector database so that you can access it. So with just a simple snippet, you can just store it to your Qdrant cloud. And the next comes is, now you have everything set up. You have the whole 1,000 of video embedded and stored in a Qdrant, and now you need to retrieve it or make use of it. So for that, you can just, as a user, I just provided a preference, right? As a dark theme and about a sci-fi. So as soon as I provided it, the text gets converted into a text embedding using the same model. And after that, it goes to Qdrant, does the semantic search, and gets me the retrieved video, as you can see here. As soon as I change my preference on based of the response I got, then it goes again with the generation of the embedding, and then again it goes to the Qdrant for semantic search. So here you can see how optimally you can make use of it. And if you see how it works, it's just a simple, like, as soon as I provide the preference here, it just does the same thing. You just need to change the parameter from video to text, and it just directly prepares the embedding vector. And as the last step, you can see here is the semantic search. And here is the architecture as a more detailed way of how all the steps works on. But here you can see how it like finds the most relevant 10 videos. And here query is the vector that we created, the text embedding. And here is like just a collection name and the query point to find the exact from that collection. So this is how like you can build any application, or I can say you can just have this as a static template kind of. You can change the use case you want to. You can have like the varied use cases, maybe from a surveillance to any other. We will be discussing about use cases you can build on, but the architecture which goes on seems to be very similar as of this, as you need to first generate an embedding, store it to a Qdrant, and you retrieve it. So next we'll see, you can steal some ideas from here. So we'll see the exploring untouched potential or some of ideas which you can build around if you are looking for cross-modal retrieval. So you can build around maybe security and surveillance. So if you have like a CCTV of a data or dash cam videos, you can just convert into an embedding, or maybe you can do have like a lot of footages. So majorly, how does it help? If some incident happens, or if you don't actually know something happened, you can't actually go through the whole 24 hours or maybe 6 hours of a video to find the specific moment. Here, you can do it in just 5 seconds by just having everything embedded, stored, and you just do the search and you get the specific thing if it's like around accident or maybe paranormal activity. I even tested it with the paranormal activity and I found that clips. If you want, I can show you after the talk. So next is the audio discovery for creativity. And this is very trending at this moment. Like whenever I had a talk with gaming agencies, and they actually want a lot of new audios and very specific audios of to be used, or maybe in video editing, they need a very specific, and it's very difficult to find audios around it. So maybe an audio, but also looking towards the licensing part of that, but just converting an audio into embedding and storing it to a Qdrant, and you can have like a faster audio discovery, which would actually boost a lot of productivity and also the creativity. Next, but not the least, is interactive learning platform. So this is very similar to the video-to-video recommendation as we have seen, because let's say you have, or maybe you are an educational firm and have a lot of videos, and it's very hectic to have a whole description out of it, or maybe the user can interact with a video or make an analysis on what all been discussed, or maybe the video you are watching, like here you can see it's about quantum entanglement, then the suggested are something around quantum itself. So because it's getting from semantic search for the recommendation here, so that it's more relevant towards it and you don't need to have a trouble of cold start or any other problems. So it provides you the precise video-to-video recommendation out of it. And also multimodal e-commerce discovery. So nowadays, you might have seen in very portals, in most of the portals, now they have real videos of the product and also have the image, also have the text. We are not solely talking about text at this moment. So at that time, if you just search around maybe a Snickers, then you will also get a video out of it, the text, and everything will be retrieved from it. So this is one of the things where you can just embed all the data you have and store it to a Qdrant, and then it actually transforms how you shop. And you can also call it as any-to-any semantic search for shopping or e-commerce. The last I would like to add on into this is you might have also like seen about the MCPs, right? So you can also do generate an embedding and store it very easily without even writing a code. So in 12Labs, there is also a 12Labs MCP. So you can just connect it with the Claude desktop and connect your Claude desktop with the Qdrant MCP, and you just provide the links of videos or maybe the directory of the videos, and from Claude desktop itself, you can just by writing a prompt, create an embedding, create the whole structure, and push it to a quadrant. So this is the way you can actually also explore the use cases and come up with something new around it. So that's all from my side. If you have anything around multimodality to discuss on or AI, you can reach out to me. Thank you.